We're live.
All right. Hello, everyone. We're very excited to get started with our meeting today, and we're hoping that you're enjoying the new platform as we go virtual. So a few things might be a little bit different, but we're going to walk you through it and then get into the meat of today's presentation. So first off, make sure that you sign in. There's a QR code in the top left of your screen. Also, we've put in some specific links in the description of this video so you can follow along. And if you miss anything from one of the slides, you can refer back to those. All right, so let's get started. If you have a question today, we're still using Slido, so you can go to sli.do and use the room code ROWDY. And if you have any questions throughout the presentation, I would highly encourage you to type them out there. We'll try our best to make sure that we're answering those questions as soon as we get them. So we may interrupt the presentation every once in a while if we get a question like that. Member dues. So if you would like to pay, you can pay online at acm-utsa.org/join, or you can just scan that QR code that's right there, and that'll take you directly to our page where it gives you more information about membership and how to become a member. And our Slack. So I think that a lot of you guys are already on Slack, but just in case there's a few outliers, I wanted to bring it to your attention that this is our main communication platform for anything ACM. Basically any announcements that we have, events or opportunities, we'll be posting it there. If you're not a member and you want to join our workspace, you can pay your dues online by becoming a member, and you'll automatically get an invite for our Slack, or you can just email council@acmutsa.org, and that'll give you a chance to speak with one of us, and we'll get you hooked up. And our social media. So make sure that you're following us on social media, especially during these trying times where a lot of us are already glued to our phones and our computers. We really want to see you guys there. So we have our YouTube channel, obviously, Instagram, Twitter, Facebook, and also LinkedIn. So if you want to connect with us professionally, you can do so at that link right there. And I just realized these aren't in our description, so I'll make sure to get those posted immediately. And our loyalty program. So I think a lot of you guys are probably familiar with this by now, but if you're not, our loyalty program is essentially a way for you to stay up to date with what we're doing. And if we see that you're at a lot of our meetings and things like that, you can get some really cool stuff. So you'll get 1 point for every ACM or ACMW general meeting, workshop, or any socials that we might have, even though they might be virtual. And then for any major events like RowdyHacks, which is coming up this weekend, you'll get 2 points. And so at the end of the semester, if you're able to achieve 20 points, if you're not a graduating senior, you'll have your fee waived next year or next semester for ACM, so you won't have to pay that $20. And if you are a graduating senior, you'll get an ACM stole. And since we're on that topic, let's talk about some of the ACM goods that we have, especially considering what's going on right now. So if you guys have been worrying or wondering how you're going to be able to get your stuff from us, like let's say you're missing a t-shirt or you're wondering about your ACM stole, we'll be collecting mailing addresses from you guys soon. So yeah, just keep that in mind. If you're one of those people, just stay tuned. We'll make sure that we post that so that everybody can see it. And if either of those options applies to you, just fill out that form and we'll make sure that we can get that to you. All right, some upcoming events. So number one, we have Rowdy Creators. So this is Fridays at 10. This is now going to be hosted on Rowdy Creators Discord, and the link for that is below. So if you're interested in being part of a long-term project or just getting to know a little bit more about what they do, I'd highly encourage you to follow that Discord workspace and to see what it's about. And RowdyHacks. So I think that we all know it's this weekend, but just wanted to bring it up one more time. So that's Saturday and Sunday. If you've already registered and RSVP'd, you should have gotten an email today with more information about like how to join the workspace and Discord and things like that. But for more general information, I would definitely encourage you to go to rowdyhacks.io. And we have an underclassmen meeting coming up next Monday. So this is going to be going over like basic web development. So it'll be HTML, CSS, JavaScript. It's going to be on Monday the 30th at 1 p.m. So that's our, never mind. So that's 1 p.m. on March 30th. And that's going to be our ACM YouTube stream. We don't have a direct link for that right now, but if you go to our channel, you should be able to catch that. Or if you're in Slack, we'll be posting it there as well. All right, so without further ado, I'm going to introduce Joseph Roca. He is kind of helping out with a lot of the backend stuff for RowdyHacks, specifically with the cloud infrastructure. So if you're interested in ways that we were able to get registrations and things like that for RowdyHacks, this is the guy that you want to hear from. So without further ado, I'm going to hand it over to Joseph.
Hello, everyone. My name is Joseph. I am on the organizing committee for RowdyHacks. I was asked to speak to y'all about the cloud infrastructure we developed. I'm also going to speak about why we chose to put it up in the cloud as opposed to a regular server, and also talk about a little bit more about the AWS services that Amazon offers. Just a little bit more about me. I graduated with my undergraduate in December of 2019. I'm currently pursuing a master's degree. I work at USA as a member of their cyber hunt team. And some of the stuff that I worked on with RowdyHacks was the applications. So if you filled out an application, I developed that web app. RowdyHacks Tally, which is our check-in application. RowdyHacks Citadel, which is our security monitoring tool. Geo, which is really cool. It's a participant school visualization. So if you go to geo.rowdyhacks.io, you can actually see the different schools that we have, the schools that people are attending who are going to be participating at RowdyHacks. And the other stuff, just the cloud infrastructure, which powers the applications, check-in, security operations, data analytics, and there's a bunch of other stuff that we've pushed to the cloud. Here's some of the applications we have. The top right, you'll see if you registered for RowdyHacks, that is our application page. The top left was RowdyHacks Tally. When we were going to have it as a in-person event, you were supposed to go up to a laptop, place your QR code that you got for the RSVP in front of the camera, and it would automatically check you in. The bottom left is the analytics tool we have, and I'll be demonstrating that. It's pretty cool at the end of the presentation. And the bottom right is the Discord bot that we're currently developing that's as a replacement to the in-person RowdyHacks Tally. Let's start with a use case. Let's say you've created like a dating website for your software engineering project called Runners Mingle. Right now you have that code running locally on your laptop, but ideally you'd like to allow others from across the world or across the school really to use your application. You have a couple of options. One is you can continue to host it on your own laptop. But what happens when you have to close your laptop, put it in your bag, and go home, right? Everyone that's on it is going to immediately lose connection, and they're not going to be able to access it till you open it back up. Also, let's say you're working on a school project, and there's a bunch of people using your app all at the same time. they're going to be using your resources while you're trying to get something done. And as a result, you're going to have a decrease in performance. And then what happens if there is some kind of security intrusion, right? All your personal data, anything that you had on that laptop is going to be vulnerable. Brings us to option 2. So you can buy another server. Essentially, you could also just buy another laptop. Now you have a computer that's on 24/7. You can finally close your laptop, but there's some other problems associated with that. So who's going to update the software? What happens when you need to move that server around? So let's say you have it at your apartment and you're moving apartments, and now you have to move it. Well, that means you have to unplug it, which means anyone that's using it, the application, will lose connection. There's some other costs associated with having a server. One is just buying it. So you can buy a laptop for pretty cheap, but as you scale upwards, it gets pretty expensive. So typically between $500 and $700, you can find a nice used server, but they go up into the tens and hundreds of thousands of dollars as an extreme use case. Well, let's say you can't afford that. You have money. Is it a waste of your money? So this is actually the RowdyHacks API calls from March 9th to March 22nd. And we see here that we have these peaks in the middle of the day, but at night and during the weekends, it tends to die off. There's not really a lot of people using our application. So it would be kind of a waste to have a computer on 24/7 when nobody's going to be using it for those 10 hours. And this is the same problem that a lot of companies have, is they want to make sure they're meeting that minimum demand, but they're also they also have to balance it between those high peaks. So some of the things, if you're buying your own server or hosting it on your own server, you're charged with keeping up with the server even when you're not serving out any requests. So it's constantly on, it's constantly taking power, you're paying for the power, you're paying for the cooling, things like that. You're responsible for the uptime and maintenance of the server and all its resources. So everything up from like the physical drives and hardware that's inside of the server, all the way to the software that's running on the server. You're responsible for everything. You're also responsible for applying the appropriate security updates to the server. That's one of the nice things about the cloud. Is what we've done is we've gone to a completely serverless environment. So we actually don't worry about a lot of the same security problems that we would worry about if we had our own server. So anything that's below the application layer, we typically don't worry about it. There are some exceptions to that rule, but we look at mainly the application security. So cross-site scripting, injection, things like that. And as a general rule, it's a pain to manage servers if all you care about is delivering a great product to the user. Since everything is virtualized in this option 3, scaling up is as easy as clicking a button. So one of the smallest computing servers that AWS offers is the A1 Medium. It has 1 virtual CPU and 2 GB of memory. But let's say you start to want, there's a large number of users coming on your service and you want to scale it up. Well, it's easy as clicking a button and you can get 96 virtual CPUs and 192 GB of RAM if you need it, which is pretty nice. So like I said, we've gone to a completely serverless architecture. So we don't worry about RAM. We don't worry about the space inside of the server. We don't worry about anything except for the application that's on top. AWS Lambda is one of the computing services that AWS offers. It's essentially a piece of code that runs on Amazon's managed infrastructure. And once you upload that code, Amazon handles the scaling, the patching, and the administration of the server. All you worry about is the code. So as a little example down there, we have a piece of Python code. And essentially, the Lambda handler is kind of like the main function. And if it runs successfully, it's going to return a status code of 200, and it's going to, in the body, it'll print out hello from Lambda. It's important to note that it doesn't have to be Python. You can have Java, you can have Go, there's Node.js, there's all types of different languages. RowdyHacks specifically uses Python just because all of our developers know it, so it's really easy to get up and running really quick with that. So a little bit more about AWS services. Lambda is only one service. AWS actually offers, they say they offer 175, but there is a lot more than that. And these services are cloud-based products that provide functionality. So things like databases, there's machine learning, There's security, which we'll talk about at the end. The computing servers, so you can have those instances where you have a server that you have to manage, or you can have a Lambda function. Business applications, a lot of people don't know this, but they actually have their own sort of version of Google Drive. So if your business is already, is already using AWS and you kind of want to move towards using Amazon services, they do have Google Drive, or they don't have Google Drive, but they have a software that's very much like Google Drive, Google Docs and all that.
Hey, Joseph,
and so the service, what's up?
We have one question for you. So if you could just answer this very quickly. So what stack, and are you using any stack or Bluetooth?
What was the second? Any stack or what?
Bluetooth.
Bluetooth?
Mm-hmm.
So the stacks that we're using is everything's from scratch, which we'll talk about in a minute. It's HTML, CSS, and JavaScript, and we'll talk about kind of the stack of services that we're using. It's not necessarily like we're using Apache and MySQL and things like that. I hope that answers that question. So some of the services that we use is Lambda. So a Lambda is essentially a function in the cloud. To store the resumes, we use S3. It's essentially a file storage platform. For our APIs that we publish, we have API Gateway. Amplify is a really cool tool that allows us to continuously deploy our applications from GitHub. So like I mentioned, the entire RowdyHacks code base is all CSS, JavaScript, and HTML. And what we do is it's all based in GitHub. So as soon as we need to push to a master branch, it's going to automatically push that to production. So as soon as we push, basically a few seconds later, it's going to be live up on the internet. DynamoDB is what we use for our database solution to store the application data. So when you fill out your application, it goes up into DynamoDB. Cognito is for the user authentication. So you had to register for an account. We use EC2. That's going to be for the Discord bot that we're making. Kinesis is kind of tricky. Basically, for our WAF logs, we have it flow through Kinesis. So anything that the WAF sees, Kinesis grabs it and pushes it to an S3 bucket. The web application firewall is another thing we use. Simple email service is an email sending service that AWS offers. We use that in addition to, I think we also use MailChimp, which is another platform. Simple notification service for notifying our admins if there's any problems with the service, we'll automatically get notified. AWS Glue is to automatically crawl the S3 data. There's a lot of other services. I won't go into all of them. Anything that is bolded white, we're going to talk about, and the rest of them are kind of just there to show you how many services AWS offers and how much we use. Like I said, the entire code base is written in HTML, CSS, and JavaScript, and it's also stored on GitHub. So we use AWS Amplifi for continuous integration and deployment. If you ever use like Google, I think it's Firebase, essentially AWS Amplifi is the less powerful cousin of Firebase. And it's really interesting seeing what the difference is between Google and Amazon. In some areas, Amazon's better, in some areas, Google's better. I definitely recommend, if you're attending ReadyHacks this weekend, to go to the Google Geo workshop that they're having. We actually used Google Geo to do some of our WAF stuff, which we'll show you at the end of the presentation. So definitely go to that if you're planning on going. So AWS Amplifi just allows us to have a fast and easy way to build and deploy our application. There's a lot of other tools, but all we really use it for is to hook it up with GitHub. And as soon as a GitHub deployment goes up, it'll automatically deploy into our website. API Gateway allows us to create and manage and deploy APIs, and the requests are then sent to Lambda for processing. So one of the things that I kind of like to remember it by is API Gateway is kind of like the mailman. It says, hey, there's the request coming in to this endpoint, and it has some data at the end of it. I'm going to take that data, I'm going to give it to Lambda, and Lambda is going to process it. So if you RSVP'd with us, you actually got a link sort of like the second URL up there. It's api.readyhacks.io/v2/RSVP/ and then whatever your username was, that's what you clicked on. And once you click on that, it's going to send you to the RSVP Lambda function that's going to change your application status in the database to RSVP. And it's also going to email you a confirmation, as well as display it on a web page. So like I said, AWS routes into Lambda, or API Gateway routes into Lambda. There's some other things that API Gateway can route into, but this is one of the most common design patterns. The red is essentially kind of like your address, and the white there with username, that's going to be the letter or the data that is going to be sent to Lambda. So you might be wondering, what does Lambda do with the username once it gets to it? It gets the corresponding user data from the API. So remember, it's getting sent that username, and then it's going to, as soon as it processes it, it's going to return the data to the endpoint, who returns it back to the user. So in this code snippet, this is not really an actual production code snippet we have. I removed the authentication for presentation purposes. But essentially what's happening is it's getting that event, that username, and it is going to do a lookup, that's that .get item in our database. It's going to get that user record, and it's going to return it back to the user. So one of the things that we do as soon as you get into our site is try to do this very exact Lambda function. And if you cannot do this Lambda function, if this response returns null, the application will then say, hey, you haven't signed up, or you haven't submitted an application. Here's the application for you to fill out your information and click submit. As soon as you click submit, it's going to refresh the page, and now it's going to try this Lambda function one more time. And by then, it should have the data in the database, and it'll come up with, you successfully signed up, and it will display some other things depending on what your application status is. This is kind of the final result of what you would see if you're targeting that API. So it's api.rowdyhacks.io/v2/user/Joseph. I've turned off the authentication for demonstration purposes, but essentially it's grabbing that entry in the DynamoDB table. And I'll kind of explain a little bit more about DynamoDB in a little bit. So DynamoDB is a key value document storage. It's a little bit different than SQL. This is considered NoSQL. One of the things I like to note is for each record, each document you have different attributes inside of it. So in this specific item you see there on the screen, there are 3 attributes. One is first name, the other is last name, and the other is user ID. Each attribute can only be a maximum of 400 kilobytes per attribute. And these attributes are grouped together in different items, and a group of items is grouped together as part of a table. So that RowdyHacks 2020 table that you saw in the Lambda function, that is a table with a group of items, and each item is an individual's user data, their application. So you might be wondering, I said that the maximum attribute size for AWS DynamoDB is 400 kilobytes. But resumes, we don't have a limit on how big our resumes can get. So they can be actually 0 bytes, or they can be a terabyte. We don't put a limit on that. We actually use S3. So instead of sending the resume through API Gateway and then to Lambda, we actually generate a pre-signed URL in the Lambda part. And this pre-signed URL is going to be sent back to the user, and then the browser is going to initiate a put request to the S3 bucket. And the reason we do that is because if we were going to have the resume pass through API Gateway and Lambda, there are certain limits to how much API Gateway and Lambda can process, how much data can actually go through it. And we would end up paying a lot more if we were to have the resumes go through there. So as a design decision, we said, hey, let's send the application data to Lambda. Lambda's going to make sure that's okay. It's going to store your application in the database, and it's going to return that pre-signed URL to do the put request into S3. So your resume doesn't go through the database at all. It actually gets put in an S3 bucket. It's a completely separate step from the application submit phase. One of the reasons why it's a pre-signed URL is we can set certain limits. So one of the things that you have to do is when you're setting up a pre-signed URL, you have to say, this is the file type I expect, and this is the name of the file. And the reason they do that is for security purposes. So I can't just go around trying to submit to random S3 buckets. So you actually have to know the file name. There's a lot of information you have to know, and it's all encoded in the pre-signed URL that's returned. I know I went through that pretty fast. I have some demos to show you. and some other stuff. First, I'd like to show you one of the other AWS services that they offer. It's called AWS Snowball, and this is for, let's say you have up to 5 terabytes of information on your computer, and you want to transfer that over to S3. So you're doing a data migration. Well, if you try to do that through your ISP, it might be pretty slow depending on your upload speed. So what they'll actually do is they will send you this box that you plug into your computer and transfer all the data into the box, and then you ship that back to Amazon. Now, you might be thinking, well, what if I run a very large company that has petabytes upon petabytes of information, and we're trying to send that data up into the cloud? Well, AWS has a solution for that too. They will actually ship you a truck that you drive up into the data center, plug it in, transfer the data down, you drive it back to Amazon, and Amazon will put it in S3 or wherever you're supposed to store it. I want to show you some of the cool stuff we have. First up is the analytics tool we use. Hopefully they don't get mad at me for showing this. This is our Kibana dashboard. So if you notice in the different services that we use the Elasticsearch service. And Elasticsearch is really cool because it's essentially a data storage / analytics tool. So it allows you to put data into a table kind of thing in an index, and then you can have these visualizations run on top of it. So you can see that we have 663 users applied, 471 RSVPs, 26 waitlists, and 1 ANA. We have our daily users applied. So you can see, it's usually Mondays and Tuesdays that are our biggest days of the week. Weekends, you'll notice that some days aren't even here because we got 0 users. There's a whole lot of different tools. I suggest playing around with this if you ever are just bored and want something to do. It's pretty cool. We were supposed to have the major of the applicants, but due to my bad programming, things are duplicated. There's a lot of other cool information that you can get from this. So all of our demographics are coming and we can see it in real time. So what's essentially happening is when you upload your application to DynamoDB, DynamoDB has a trigger to send that information to the Elasticsearch service. And it does this through a Lambda function, actually. So this is the Lambda function that's ran. Every time you update your application, it runs this Lambda function and duplicates it into our Elasticsearch service. This is the RowdyHacks Geo application that I was talking about. These locations are actually, we had school names, and what we want to do is convert them into addresses and latitude and longitudes. So what we did is we used the Google Geo API that they have and converted those. So you can see the different schools that people attend. So this is Middle Tennessee State University. It's really cool to see, just the wide variety of people that are going to be attending RowdyHacks. We even have international students attending, India, Kashmir, Sydney. Now it gets kind of interesting. We have an AWS WAF, and what the WAF does is it sits in front of our API gateway endpoints, and it monitors the traffic for any kind of anomalies. And it will automatically, through that Kinesis firehose, dump all the logs into S3. And what we did is we queried S3 and found, and we did that, taking an IP and converting it to latitude and longitude. And we can see the different, like the general location of where people are applying from. And we can see that this IP was blocked from a remote file inclusion. So people that try to do things that are not safe, they get blocked by our WAF, and we can see all of that information. It's pretty cool. As a security person, this was kind of my personal project. Nobody really asked me to do it, but I wanted to do it because it's cool.
Joseph, we have a couple other questions.
Yeah, go ahead.
All right, so the first one is, why did you end up working with AWS as opposed to other cloud services?
Yeah, so that's a good question. If we were to go back right now, I think I would rather do it on Google Cloud. we set up actually a lot of different guides on how to do things in AWS, and I know that Google is doing a their own challenges, so it would have been nice to have those guides up for Google. Essentially, the differences between AWS and Google Cloud is they're pretty much the almost exact same thing for some of these services. They have the, like, I think Google Cloud calls it Google Cloud Functions and AWS calls it AWS Lambda. The reason we decided to go with AWS was just because we had a more experience in working with AWS. That's really all it is. That's really all there is to it. I think it's good to go and try the different cloud providers, and it also adds resiliency, because one of the things that we didn't tell you is a lot of our servers are actually, or all of our services are actually located in North Virginia, and North Virginia actually tends to go down once every couple of years, just from, I personally think it's cursed, but I don't know. Is there another question?
Yeah, there's a follow-up to that one, and it was just, how did you first learn AWS?
Yeah, so there's actually a funny story about that. And I will answer that with a demo. So this is an application I wrote in my operating systems class about 3 years ago. Essentially, we were pretty bored in class and decided to write a game. So what I'll show you right now is AWS Amplifi, how you can just quickly connect that. So we have this GitHub repo. I'm going to select GitHub, continue. And once I do this, I will finish answering that question. Select the branch. I'm going to select the master branch. Next, save and deploy. So while that's baking, I wanted to host this exact project for my friends to use in the operating systems class, so we could play it. It's essentially like a clicker game. So one of my friends suggested using AWS, and that's kind of how I learned. I started out with EC2, which is essentially just a server up in the cloud. I hope that answers it, and hopefully this, it takes a while to verify and build and all that. Is there any more questions?
Yes, there's another one we just got in. Are the dashboard graphs auto-populated, and can you explain how the data is populated? I think it's referring to the Kibana.
Kibana? Yeah, so they're all well, they're not auto-populated. Essentially, we have to set that up. So if we go to dashboard, actually, dashboards are actually a collection of visualizations. So you would click this, and there's a lot of different visualizations you can use. So if I want to get like a metric, let's say the telemetry index that we have, those are all the records in there. And what I can do is I can split the group on that term by maybe user agent. And that's the total of, that's the different user agents. So as people are using our application, we can kind of see what are the most popular user agents. And also with our telemetry, we get errors back, and it's really helpful to see what kind of errors people are having and what user agents correspond. So we'll know if there is a problem using mobile Safari based on the errors we receive. So that's pretty much auto-populated based on our code. Our code sends that telemetry to DynamoDB. DynamoDB then triggers a Lambda function, which inserts into this record. So it's all auto-populated from that pipeline. Oops. Any other questions?
That's all the questions for now.
Yeah, so it looks like the deployment, it should be done. So if I click this, it should be up. So we see that it's up and running, and that's how easy it is to deploy. And if we actually just push another update to this, so let me go to clicker. There's a way to get it to December is month 11. So this should be month 2012. Hopefully that works. If it doesn't work, it's going to be a problem. And just while that's baking, we typically use this blueprint kind of thing. It's cloudcraft.co. So it's really helpful to kind of keep your infrastructure in line, because as you can see, we have Lambda functions and DynamoDB and API gateway, and they all kind of form this kind of mix of different services. So just a simple diagram. This is your user, and they're going to this API. That API is going to forward that information to the Lambda function, and that Lambda function is going to do something with the database and send it back. And just to show you how complicated it gets, this is a very small portion of what we have. And this is the total, actually this isn't recent. This is from about a month ago. So this is actually what's happening. So we have the pre-signed key, there's Amplifi, the WAF that sits in front of API gateway, the different Lambda functions we have, the DynamoDB tables, more Lambda functions. All of our logs go into CloudWatch, and then we have a alerting infrastructure that uses that simple notification service to alert incident responder, which is me. If there's a breach or anything weird going on, all that data is being populated into there, and it does some different things to kind of detect anomalies and will notify me if anything fishy is going on. It should have deployed now. There we go. So you see, all you have to do is do a push and it will deploy. All I did was change the month to be March, and it displays something different. It was a little special Easter egg that we had for the month of December. That should be all. If there's any questions, I'll be happy to take those. If not, I'll pass it back to Matt.
All right, no questions yet. So anyways, well, thank you so much, Joseph, for running us through that. That's like really, really interesting stuff. I'm so glad that we got a chance to kind of see some of this stuff behind the scenes. We just got another question. Do you currently use AWS on the job?
No. So actually, my role has nothing to do with cloud. So yeah, it's kind of interesting. I do this more for fun and because I like it. And on the job, I also like that stuff too. But there are cloud teams. So if you're interested, if you ever have a chance to apply for like a cloud security team or a cloud development team at USA, there's a lot of internships and job opportunities. So just make sure you're checking on that when you're going job hunting. Anything else?
We got another question, a question that I personally would like answered as well. How many hours have you spent on this?
Oh, that's a very good question. In the last week or in the last few months?
Let's say total, if possible.
Total. That's a good question. The original idea for this is that it's all going to be a one-click upload. So essentially one of the AWS services is called CloudFormation, and it's basically a JSON file that you can run, and it'll actually stand all this infrastructure up for you. You don't have to do anything. So we're currently working on getting that, and hopefully that will be open sourced if the company lets me open source it. There's some things I have to do with regards to what's it called? I'm forgetting the word, but we want to open source this technology so that other hackathons can then use it. Because what you'll see at a lot of other hackathons is they have 10, 20 developers working on a project, and we've basically done this with 3. So it's really powerful to use the cloud. And the total number of hours I spent is probably close to the 100-hour range. Any other questions?
We have another one. Can you tell us about some of your side projects? So anything non-work related?
Anything non-work related? Well, there's this one. That was fun. Non-work related. Oh, Avalon. Avalon was actually one of the first things I decided to do as far as serverless cloud architecture. This is kind of what spawned the RowdyHacks project. Avalon is essentially, I don't have it up and I don't want to put it up, but it's essentially an Instagram clone. And that's one of the side projects that I worked on, basically redoing Instagram, but in AWS serverless architecture. Some of the other projects that I've worked on, yeah, there's a lot of stuff. Basically every final project that I do, there was this one. This is an automatic implementation of one of the vulnerabilities for iPhone that came out I think it was 2 years ago. Yeah, 2 years ago. I automated that and could turn off iPhones if you were connected to the network. That was pretty fun. Rowdy Talk, that was a few years ago. Essentially, this was a JavaScript, or not JavaScript, it's a Java chat application. Basically, there's a server and clients. That was pretty fun. Anything else?
I believe that's all the questions that we have.
Awesome. I'll turn it back to you then.
All right. Well, once again, thank you so much for going through all of this. Really, really interesting stuff. If you guys have any questions for Joseph about anything that he talked about or want to learn more about some of the things that he might have brought up, I'm going to just let you know that you can talk to him on Slack. Hopefully that's okay with Joseph. And so his name one more time is Joseph Roca. And of course, if you have any questions for us, any ACM officers, anything like that, feel free to reach out to us. Just DM us in Slack or email us. And with that being said, thank you guys for attending, and we'll see you guys next week.
Yeah.